In the previous video, I talked about how useful number lines can be for a lot of math skills and at least showing your thinking, but there is kind of one roadblock that makes them a little bit more challenging, and that's determining what interval do I use when I'm drawing them. And just a reminder that an interval is the amount of space or the value of the space between the tick marks. And so if you're given a situation where you need to place 41 hundredths and 48 hundredths on a number line, you need to figure out, like, what is going to be my endpoints, first of all, and then what are my values going to be. So when we're doing our number lines, you want to be thinking about what is the relationship between these two numbers. How might they be related? And so I know that 41 hundredths is really close to 40 hundredths, or 4/10, and 48 hundredths is pretty close to 50 hundredths, or 5/10. And because those are our benchmark numbers that we can use for comparison, I'm going to also use those as our endpoints. So here is 4/10, here is 5/10. From previous years, you also know that 4/10 is equivalent to 40 hundredths and 5/10 is equivalent to 50 hundredths. So I'm going to erase those for now, though. So if we're looking at this, we need to then figure out, one, how many tick marks do we want, and how far apart do they need to be? So I notice 41 hundredths is odd. That hundredths place is an odd number, and then 48 hundredths, this is an even number. So I can't count by twos, so I am going to have to count by ones. And so I'm going to end up putting about, I think, 10 tick marks in between there. So I want these to be about equal, and so when I'm doing numbers like 10 or even numbers, I like to split it in half and then chop it up from there. So on this side, I need 1, 2, 3, 4 more, and then over here, 1, 2, 3, 4 more. And so by starting with that halfway point and then dividing them after that, you can see this actually turned out to be pretty even. I feel actually quite good about that. So now that we have this here, because we're counting between 4/10 and 5/10, I can't use an interval of 1/10, because if I did that, 1/10 would get me right from 4/10 up to 5/10. So I need something smaller than a tenth. And if I remember my place value chart, I'm going to do a real quick little sketch here. Here's my place value chart. I know we have ones. Here's our decimal point. Tenths. Hundredths. And we'll add thousands on there. And so if we're working in this tenths place, if I look to the right, I know that's going to be my next place smaller, and so I can use hundredths as my interval for this. So I know if I count up by hundredths, I would have 41 hundredths, 42 hundredths, 43 hundredths. So I'm going to skip right here to the middle, because I don't need to number every single one of them, because I know my interval is 1/100th, and I'm increasing by that constant amount the whole way. So now that I've got my interval, I have my endpoints, I've got my tick marks divided up, I can now place 41 hundredths and 48 hundredths. 41 hundredths is just 1/100th more than 40, and 48 hundredths is going to be 2 intervals less than that 50 hundredths. So if I wanted to, I could write these as 40 and as 50. So going back to our list over here, for our steps, first you had to determine that relationship, then you had to think about what are some benchmark numbers that you can use as your endpoints, and then you need to determine your number of intervals, and then you got to space them out. And then draw them, and then figure out what is the value of the intervals. So if we look at, let's say I want to place 1 and 1/4, and then 1, and how about we go and 2 and 1/4 on a number line. So those are going to be our numbers that we're looking for. So I have to figure out what is the relationship between these. Well, I know they're pretty close. They're within 1 of each other, and it looks like they're using, we're not going to be doing whole numbers, but we're going to be using fractions. And they have a common fraction of like the 1/4. So that's already starting to tell me that like, maybe that could be a good interval. So I'll draw my number line. I know the relationship is that these are related somehow with fourths. And because I don't want to use these numbers exactly as my endpoint, I'm going to go down 1/4 and say, well, this is between 1 and about 2.5. And so if I'm doing 1 and 2.5, that means I can break those up into small chunks that will allow me to place the fourths on there. So if I decide that, I want to be able to figure out my value, it would make sense that I've listed out the multiples of 1/4 because that will get me both of these fractions. And so I need to figure out how many fourths are there between 1 and 2.5. Well, I know between 1 and 2, there are 4/4, and then between 2 and 2.5, there's going to be 2/4. So I need to kind of break these up so that way they are all about the same size. And if I check this out, with an interval of 1/4, I would get 1 and 1/4, 1 and 2/4, which is the same as 1.5, 1 and 3/4, 2, which is 1 and 4/4, and then 2 and 1/4, and this is 2 and 2/4 there. So our interval of 1/4 looks good, and now we can place 1/4, and we can place 2/4. So these are a couple good little examples there, but there are some patterns and some generalizations that we can use when we're working on our number lines. And so if we are looking at a number line, and then we've got some place value things. So we notice that up here, because we were looking at tenths, we ended up using the hundredths. So we know that when making a number line, you are going to typically, your interval will typically be 1 place less than your benchmark, or than your endpoints. I forgot the D in there. So if we were to think here, like if we have these endpoints, this is what our interval would be. So if we have an endpoint of like 10 and 20, these values are both in the tens place. So that means our intervals will likely be in the ones place because that is 1 place less on the place value chart. Same thing if our endpoints are from like 1 to 3, we're dealing with the ones place. And so our interval is going to be a tenth because that's going to be our next smallest piece. If we're looking between, let's say, 2/10 and 3/10, we don't have any tenths in between there, so we need to go to our next smallest place, which would be the hundredths. So you could do an interval of 100ths. And if we did a little number line here, just as a quick sample, 2/10 and 3/10, we know there's 10 hundredths in between there because these are equivalent to 20 and 30 hundredths. So we could do an interval of 1/100th, and that would get us an appropriately created number line. And you could continue this on and on. And what's nice about this is it works for decimals, and then you can also convert fractions to decimals. So I'm going to quick add a new page here. So what does this look like then if we have fractions? So let's say you are dealing with, let's say, intervals for fractions, and they have with uncommon denominators. So that might be something like 3/4 and 1/8. So we're going to be trying to figure out what would be a decent interval to use for those two fractions. And if you look at this, I need to center this because that'll make me crazy. So we know that our denominator of fourths and eighths, I can count by fourths. That would be like 1/4, 2/4, 3/4, on, but I'm never going to land on this eighths. So I'm going to go to the next smallest related fraction, which is going to be those eighths, because if I do 1/8 and then 2/8, these are actually equal. 3/8, 4/8. So here we are. We have those equivalent fractions again. 5/8, 6/8. So you can find related pairs or like fraction families basically to help you come up with what would be a good interval for your fractions. So if you have some sort of a fraction that has a 2 as a denominator, you might be able to use, depending on what your other fraction is, fourths as an interval. So we could say, we'll call this like our base or our endpoint fraction. Endpoint could be a fraction with a 2. So your interval, this is in the wrong place, sorry. All right, so your interval could be something with a fourths or maybe sixths, depending on your fraction, or eighths, tenths, perhaps. If you have a fraction with a 3 in the denominator, your interval might be thirds. It could be sixths, could be ninths, could be twelfths, and it all depends on what the other fraction is. Same thing with, we did, I don't know, fourths. We could have an interval that is fourths, or maybe it's eighths, or maybe it's twelfths, maybe it's sixteenths. So, and that's like what we saw in our example up here. And you could carry on with this over and over. So if you're thinking back to what we did last chapter, where we were looking at least common multiple and greatest common factor, we can actually use that thinking here to help us out, because our example up top in this section, these are pretty similarly related. They're pretty easy to see that, oh, I know fourths and eighths are pretty well related, but what happens if you have fractions that aren't quite as obviously related? So if we have 1/4 and say 1/6, and we need to place those both on a number line, it doesn't quite fit real well here, but because we do know least common multiple, we can use that to figure out what could our interval be. So our least common multiple, if we did a quick ladder, or this one's, you could probably think it out, least common multiple is going to be 2 times 2 times 3, which equals 12. So our interval for this fraction pair could be twelfths. So if we had a number line that starts at 0, and these are both pretty small, so I'm going to stop at 1/2 or 6/12, I could divide this up 1, 2, 3, 4, 5, and 6 into our 6 pieces, because that's how many twelfths we have, how many intervals. This is 1/12, this is 2/12, or 1/6. This is 3/12, or 1/4. We have 4/12, which is 1/3, and 5/12 here. And so using this interval of twelfths, we are able to place 1/4 and 1/6. Check it out. So if we're coming up with those rules, we could say, I'm going to write this in like purple because this is key, that when number lining fractions, use the LCM to determine your interval. And so here you can see how these ideas are quite connected. Now, the next step in this process is what happens if you have something like a fraction and a decimal. Those are a little bit more difficult to compare, but we do know things about equivalencies and values, where we know 2/5, that does have a decimal equivalent. So 2/5 is equivalent to 4/10, and that is the decimal of a 4 that ends in the tenths place. 75/100, well, that if you read it using place value language, you definitely know that that is equivalent to 75 over 100, and you might also recognize that that is 3/4. So if we wanted to use our idea from above of using least common multiple, we need to find what is the LCM of, we should add here, LCM of the denominator. So the LCM of 5 and 4. And we know if we were to do our double ladder, there's no common factors. So we would just need to multiply, and 5 times 4 is 20. So we would need to show 20ths on our number line. So we're going from 4/10 to 75/100, 4/10 to 3/4, or I'm sorry, 2/5 to 3/4. Let's start out with our, let's see, 4/10 is definitely less. We need a 20 in our denominator, so we know that 2/5 is equivalent to 8/20. And 75/100 is equivalent to 15/20. So we need to have a number line like that. So that would mean in between we have 7 tick marks. 1, 2, 3, 4, 5, 6, and there's our 7th. And each one of them is 1/20. Oh man. And check it out. It does actually work. So we know we could have a number line like that. Looking at our decimal style, though, I'm going to just do this down below. We need to have our decimals between 4/10 and 75/100. Stick my arrows on there. I'm going to turn this 4/10 into a 40/100 because I know that those are equivalent. And now we need to figure out, in between, the difference of our endpoint is 35/100. So let's think about what factors we know of 35/100. Oh, wow. That's kind of wild that it does that. I don't know what happened. Sorry about that. So I know the factors of 35 are 1 and 35, but I don't really feel like drawing out with an interval of hundredths. I don't need 35 little tick marks there. I also know, oops, we have 5 and 7. So we could do 5 intervals of 7/100, or we could do 7 intervals of 5/100. And typically, you want to pick an interval that's of a more friendly number. It's much easier for me to count by 5s, so I'm going to go with this 7 intervals of 5/100. So I need about 1, 2, 3, 4, 5, 6, and 7. Those are approximately. And I know each interval is going to be 5/100. So that would make this 45/100, 50/100, 55/100, 60/100, 65/100, 70/100, and then 75/100. So using some of these steps and building on our reasoning and all of the lessons from the past, you can see how you can figure out like what's our interval going to be and then how can I represent that on the number line.